Chemicals from common salt. Sodium chloride is a very useful raw material for different chemicals. Seawater contains many different salts dissolved in it. Sodium chloride is generally obtained by evaporation and purification of seawater. Mountains of salt are available as rock salt. Rock salt is mined from rocky mountains. A few out of these are hydrochloric acid, that is HCl, sodium hydroxide or caustic soda, sodium carbonate, that is washing soda, Na2CO3 10H2O, baking soda, denoted by NaHCO3, and bleaching powder. Caustic soda or sodium hydroxide, that is NaOH. Sodium hydroxide, commercially known as caustic soda, is a very strong base. Let us learn about manufacturing of sodium hydroxide. Sodium hydroxide is prepared on a large scale by passing electric current through a concentrated solution of sodium chloride, that is brine. The following chemical reaction takes place. 2NaCl in aqueous state reacts with 2H2O in liquid state to give 2NaOH in aqueous state plus H2 in gaseous state and chlorine Cl2 in gaseous state. The process of electrolysis is known as chloralkali because of the products formed, that is, chlor for chlorine and alkali for sodium hydroxide. In this process, hydrogen gas is evolved at cathode and chlorine at anode. The solution which is formed is sodium hydroxide. All the three products obtained from the process of electrolysis are useful both in industry and in the laboratories. Uses of caustic soda. Sodium hydroxide or caustic soda is used in the manufacture of soaps, detergents, paper, rayon or artificial silk, and a large number of chemicals. In cotton industry for merchandising, that is making unshrinkable cotton fabrics. In the refining of petroleum, in the preparation of soda lime, which is a mixture of NaOH and CaO. As a cleansing agent for machines and metal sheets. As a laboratory reagent. Let us now learn about uses of chlorine. Chlorine is used in sterilizing drinking water and also as cleansing agent in swimming pools. This is because of the germicidal nature of chlorine, which kills harmful bacteria present in water. In the manufacture of polyvinyl chloride, PVC, chlorofluorocarbons, CFCs, and chloroform, CHCl3, etc. In the commercial preparation of bleaching powder and hydrochloric acid. In the manufacture of pesticides and disinfectants. Uses of hydrogen. Hydrogen is used in the hydrogenation of edible oils such as groundnut oil, cottonseed oil, etc. to form vegetable ghee, also called margarine. In the manufacture of compounds like ammonia, water gas, that is CO plus H2, and methyl alcohol, CH3OH. As a rocket fuel in liquefied form, and in the manufacture of hydrochloric acid. Chlorine gas can be obtained from electrolysis of sodium chloride solution. From this chlorine, bleaching powder can be produced. Bleaching powder is also known as calcium hypochlorite. The formula of bleaching powder is CaOCl2. This animation shows the Hazen-Cleaver's industrial method of preparation of bleaching powder. The plant consists of 4 cylinders in inclined position. Each cylinder consists of a stirrer to ensure mixing of substances. There is an inlet in the uppermost cylinder for calcium hydroxide. The bottom cylinder has an inlet for chlorine and outlet for bleaching powder. Each cylinder is connected to the other by means of pipes. The slaked lime is introduced in the first cylinder with the help of the compressed air. Chlorine gas is introduced from the lowermost cylinder. When proper saturation is reached, the product is separated from the last cylinder as bleaching powder. Properties of bleaching powder. It is a pale yellow powder. It has strong smell of chlorine. It is soluble in water, but a clear solution is never formed due to the presence of impurities. On long standing, it undergoes auto-oxidation into calcium chlorate and calcium chloride. 2CaOCl2. In the presence of cobalt chloride, it loses oxygen. 2CaOCl2 in the presence of cobalt chloride gives 5CaCl2 and oxygen. It loses its chlorine by the action of dilute acids in excess. CaOCl2 reacts with HCl to give calcium chloride, H2O and chlorine. This animation shows the bleaching action of chlorine. The animation shown here depicts the bleaching action of bleaching powder on cloth. Bleaching powder is in the powdered form. 1 teaspoon of it is added to water. When a cloth piece is dipped in it, changes taking place at micro level are shown. CaOCl2 reacts with water to give CaOH whole twice plus chlorine. The chlorine gas which is liberated reacts with water to form HClO and HCl, and it decolorizes the cloth. This bleaching action is permanent in nature. The HClO formed further breaks up into HCl and nascent oxygen. Chlorine reacts with water to give HClO and HCl. When moist air is there in the atmosphere, carbon dioxide molecules react with bleaching powder, thereby releasing the chlorine gas in air and making the compound inefficient. Thus, a cloth dipped in it will not get bleached as shown in the animation. CaOCl2 reacts with CO2 to give CaCO3 and chlorine. In layman's language, this means that the bleaching powder loses effectiveness when exposed to air. Uses of bleaching powder. It is used for sterilization of drinking water. It is used for bleaching cotton, linen, in textile industry, etc. It is used in rendering wool unshrinkable. The animation here shows the uses of bleaching powder. It is used in the paper industry. The chemical formula for baking powder is NaHCO3, and it is also known as sodium bicarbonate or sodium hydrogen carbonate or bicarbonate of soda. The salt has many related names such as baking soda, bread soda, cooking soda, bicarbonate of soda. Common salt provides one of the raw materials for the manufacture of baking soda. NaCl in aqueous state reacts with H2O in liquid state and carbon dioxide in gaseous state and ammonia in gaseous state to give NH4Cl in aqueous state and NaHCO3 in solid state. Sodium hydrogen carbonate, being insoluble in cold water, precipitates out as a solid, leaving behind ammonium chloride solution. Filtration of solid sodium hydrogen carbonate from the solution, followed by drying, gives pure solid sodium hydrogen carbonate. Sodium bicarbonate is primarily used in cooking for baking, where it reacts with other components to release carbon dioxide that helps dough rise. Making it fluffy and light in weight. 2NaHCO3 in solid state gives Na2CO3 in solid state and H2O in gaseous state and CO2 in gaseous state. It is also used in kitchens in cooking chana, breads, gulab jamuns, and crispy pakoras. Let us now have a look at the properties of baking soda. It is a white crystalline powder sparingly soluble in water. It is a mildly alkaline solution. pH of the aqueous solution is between 7.25 to 7.5. Since it is slightly basic, it is used to neutralize acids. On heating during cooking, sodium hydrogen carbonate decomposes between 50 degrees Celsius to 100 degrees Celsius, giving bubbles of carbon dioxide. Sodium bicarbonate on heating gives sodium carbonate, carbon dioxide, and water. Let us now discuss the uses of sodium bicarbonate. Used in the preparation of carbon dioxide. Used as a constituent of baking powder and in effervescent drinks. Baking powder has sodium bicarbonate and tartaric or citric acid. When it is dissolved in water or heated, carbon dioxide is produced. This carbon dioxide gas causes the puffiness and lightness in cakes, biscuits, etc. It is used as an antacid to remove acidity. Due to its alkaline nature, it reacts with excess acid generated in the stomach and neutralizes it to give relief from acidity. Sodium bicarbonate is used to extinguish fire as it produces carbon dioxide gas. Let us now have a look at soda acid fire extinguisher. Let us try to find out how does it work. In this type of fire extinguisher, baking soda slurry in water and sulfuric acid solution are kept separately in different containers. When the knob is pressed or cylinder is inverted, sulfuric acid comes in contact with baking soda, releasing carbon dioxide. 2NaHCO3 reacts with H2SO4 to give Na2SO4 plus 2H2O and 2CO2. Since the quantity of gas is more and the volume of the container is small, carbon dioxide comes out of the nozzle of the container with force. Although the temptation is to aim the extinguisher at the flames, the proper way to use the extinguisher is to aim it directly at the fuel. Aim at the base of the fire, not the flames. This is important. In order to put out the fire, you must extinguish the fuel. Sweep from side to side. Using a sweeping motion, move the fire extinguisher back and forth until the fire is completely out. Operate the extinguisher from a safe distance several feet away and then move towards the fire once it starts to diminish. Washing soda is a chemical obtained from sodium chloride. It has a chemical formula of Na2CO3 10H2O. It contains 10 water molecules of crystallization. The first reaction is manufacture of baking soda, that is sodium hydrogen carbonate. The animation here shows an overview of a plant where washing soda is prepared. We will be discussing each process in detail. Beginning from left to right, we will have a look at the saturating tower, carbonator, lime kiln, slaker, drum filter, and the ammonia recovery chamber. The first one is the saturating tower, where ammoniacal brine is prepared. As you are seeing in the animation, aqueous ammonia on the left is added to brine, which is shown on the right side to a chamber containing water, which results in the formation of ammoniacal brine. Let us now have a look at the lime kiln in the animation. Let us have a look at what goes on inside it. Calcium carbonate is present, which is heated. On heating, it decomposes to form calcium oxide and carbon dioxide. This can be written in the form of an equation. CaCO3 on heating gives CaO and CO2. Carbon dioxide escapes from the top. Let us now have a look at the carbonator chamber. It consists of a number of horizontal plates. Let us look at the zoomed view of the plates. These plates are perforated. The ammoniacal brine falls through the top and mixes with the CO2 from the lime kiln. Observe the reactions taking place in the form of equations. It is filtered by means of a rotary vacuum filter to separate sodium hydrogen carbonate. The solution which comes out of the carbonating tower is rich in sodium hydrogen carbonate. The content is in the form of a fine suspension. The mixture has been shown being filtered in a drum filter which separates sodium hydrogen carbonate, which is separated as an insoluble mass. Decomposition of sodium bicarbonate takes place in the calcination tower. Sodium bicarbonate decomposes to form sodium carbonate, carbon dioxide, and water. You can see the carbon dioxide escaping. This CO2 is then recycled to the carbonator. NaHCO3 on heat treatment has been shown decomposing into Na2CO3, water, and carbon dioxide. Carbon dioxide is recycled. Sodium carbonate is collected in water to form washing soda. Sodium carbonate is utilized by many industries during the manufacture of different products. The most significant user is the glass industry, which uses sodium carbonate to decompose silicates for glass making. The cosmetic industry uses it for manufacturing soap. The chemical industry uses it as a precursor to numerous sodium-containing reagents. It is also important in photography, the textile industry, and water treatment. In addition to these industrial applications, sodium carbonate is used in medicine as an antacid. Let us have a look at the properties of washing soda. Washing soda is a white crystalline solid. It is soluble in water and its solution in water is of alkaline nature. That is, pH is more than 7. It turns red litmus paper blue. Upon strong heating, it loses the molecules of water of crystallization and changes to anhydrous salt, which is a white amorphous powder. It is called soda ash. Washing soda has the property to remove dirt and grease from dirty clothes. That is why it is called washing soda. Uses of washing soda. Washing soda or sodium carbonate is one of the most useful chemicals in industry. In the manufacture of glass, paper, and also chemical like caustic soda, that is NaOH, borax, Na2B4O7, and baking soda, etc. In the laundry for washing clothes and as a constituent of a number of dry soaps, as a cleansing agent for domestic purposes, for removing permanent hardness from water, as a useful reagent in the laboratory.